Hello and welcome. In this video, we're going to take a look at the new presets panel in PyMOL 3. By the end of this tutorial, you'll be able to understand the difference between object-specific and globally applied presets, apply, edit and create new presets using the PyMOL 3 presets panel, and further understand the importance of property selectors and selection algebra. Let's get started. This video follows on from previous video tutorials where we took a look at almost all of the PyMOL presets that can be found in the Actions submenu. I'm going to load in this same session so that we have multiple objects in the Contents panel, but you can create a new session and load in anything else you like here. Now let's type fetch1n8z in the command input area. We're going to start by styling this with the object-specific preset that's in the Object's Actions submenu to see how the protein interface preset looks. Looking good. To learn more and get hands-on with this human HER2 epidermal growth factor receptor and Herceptin Fab antibody complex, check out the Introduction to Computational Antibody Engineering Schrödinger online certification course. A reminder here that applying a preset in this object-specific manner will not alter the representations of any other objects in our Contents panel. With that in mind, let's save this as a new session before moving on, as we're going to be making some edits. Now let's try out the Presets panel, which is new to PyMOL 3 and is designed to give users a way to customize and create their own presets. Click on Presets in the Action toolbar to launch the Presets panel. We can see there is a preset here called Protein-Protein Interactions. Select this, then click Apply in the panel. This is a little different from the Protein Interface preset, as there is a surface at the Protein-Protein Interface now. With this preset, the view also zooms in to highlight the visible interfaces, which is pretty nice. Say we wanted to edit this preset. We can see that we can easily do this by clicking on the Edit button in the Presets panel. Here we can choose from a list of common selections and a number of options. Take a minute to look through the interface selection options, particularly the selection string, and check out the summary table to understand how this preset currently works. You can learn more about the ByRes and zoom commands in the PyMOL command reference and on the PyMOL wiki. And remember to check out the selection algebra, property selectors, single word selectors, and coloring references. Let's keep our edits simple and choose Solvent in the Selections menu. Then, under Representations, check Spheres. Under Color, let's choose Color by Element. Let's see how this looks by clicking the Apply Now button in the lower left corner of the panel. We can now see all of the water molecules represented as red spheres. Let's save this as a new preset and close the Edit panel. Back in the main presets panel, we can see that our edited version of the Protein-Protein Interactions preset has been added to the list. If we right-click, we can rename this copy. I'm going to call it Protein-Protein Interactions with Solvent. Nice. When applying a preset from the presets panel, keep in mind that this is equivalent to setting the preset from the All object, so the changes are global and will be applied to all objects in the Contents panel. Now we can really understand the importance of saving our session before applying any changes in this panel. To make a more scientifically interesting edit to our Protein-Protein Interface preset, we could do something like highlight only the protein-protein interactions between the antibody and antigen. This requires some knowledge of our structure, and for 1N8Z, the C chain is the antigen, and the A and B chains are the light and heavy chains of the antibody, respectively. The antigen binding fragment, or Fab region, of this multi-chain antibody is the therapeutic agent here, with the proprietary name Herceptin, or generic name trastuzumab. This preset is using the ByRes command to select residues from a different chain that are within a certain number of angstroms of another chain. The preset currently only considers a two-chain protein, chain A and chain B. We're less interested in the interactions between our A and B chains, since they are both a part of the antibody. What we want to do is highlight the interactions that involve the C chain, the antigen. Let's edit the selection from ByRes, chain A within 3.6 of chain B, or chain B within 3.6 of chain A, to ByRes, chain A within 3.6 of chain C, or chain B within 3.6 of chain C, or chain C within 3.6 of chain A or chain B. Take care with your parentheses placement here and check the video transcript or captions if needed. Nice! We can now see that only the protein-protein interactions between the antibody, A and B chains, and the antigen, the C chain, are highlighted. I'm going to rename this edited preset antigen antibody 1N8Z, since although it's a global preset, the edits we've made are pretty specific for this structure. Finally, let's create a brand new custom preset that's different from anything else currently available in this list. In the Presets panel, click on the Add button. We're going to recreate a PyMOL-like representation, which can be found in the PyMOL wiki gallery. Click OK, and we can now see our PyMOL-like preset at the bottom of the list of the Presets panel. Click Edit, then under Selections, choose All. Now we're going to scroll down to the Additional Commands section. Here you can input anything that you might usually type in the command input area, or include in a PyMOL script, so this is really powerful. Let's navigate to the PyMOL wiki gallery and copy the commands we want. Since we want this preset to be usable for all structures and not just the specific example shown here in the gallery, we're going to copy from the set color oxygen command to the unset depth Q command. Paste that straight into the additional commands box. And let's see if this is working like we expect by clicking Apply Now to apply this to our visible 1NBZ structure. Amazing! This looks good. Click Save. New and customized presets are saved along with a session, and I'm going to save this edited session with a new name. As well as saving PyMOL sessions in order to share work with others, the new presets panel allows us to export and import presets directly. This is really handy if you edit or create a preset that you want to use across different PyMOL sessions, and of course makes it easy to share your beautiful customizations with others. Let's export the PyMOL-like preset now so that we can use it again in a future session. Again, applying presets from this panel applies them globally, so we can see that all of our structures are now displayed using this representation. But we can quite easily differentiate them again using the object-specific presets, or by reinitializing PyMOL with original settings, or if atoms have been removed like the solvent in this example, reinitializing everything and loading in our previously saved session. Object representations aren't the only thing that we edited in this preset. Some of the settings we used in our new PyMOL-like preset, from BG white through to unset depth Q, changed global settings in PyMOL such as the visualizer background color and lighting effects. This is why it's a good idea to save your session before testing out or applying new presets, and be prepared to reinitialize PyMOL if needed. To learn more or to reverse some of these changes manually, take a look at each of the commands in the PyMOL command help or the PyMOL wiki, and try them out one by one in the command input area. You can also find some of the global display settings, such as background color, in the display menu. In the next video tutorial, we will start to explore image creation and ray tracing, so more on this soon. That brings us to the end of this tutorial. You can now understand the difference between object-specific and globally applied presets, apply, edit and create new global presets using the PyMOL 3 presets panel, and further understand the importance of property selectors and selection algebra. Thanks for watching.